Okay, good morning students. In today's lecture, we will cover the remaining part of the conditional statement that I have already told you in the last video. The two concepts are remaining: else if ladder statement and switch case statement. Else if ladder, that is also called if else if ladder. The syntax for this is like this. We first check the test expression. Let's say I have tested a test expression 1. If it is true, statement block 1 will execute. Now otherwise the test expression 2 will be evaluated, and if it is true, the statement block 2 will execute. Otherwise, and if we want to continue at the same, we can go to the else if again, and test expression 3 may be evaluated. And at last, when the condition we don't want to change, by default we want to execute, then that part will be put in the else of the last statement. Means here for this example, if test expression in this else if ladder, we come from top to down, we keep on testing expression, and if the test expression results true, the statement associated with that test expression will execute. Otherwise, we move ahead and test some another condition. If the another condition is true, the statement block associated with that code will execute. Otherwise, we will move ahead and test some another condition, and if that condition execute, the statement block associated with particular that condition will execute, and if not any of the condition is met, then the else part, that is last else of the expression, will execute. Means when we want to make multi-way branching, here we are making multi-way branching. We have a number of codes, we have a number of statement, we have a set of different set of statement. If statement there are, if the means statement there are number of blocks of statement, and we want to execute different blocks depending upon different condition. If this condition executed, execute. If this condition satisfies, execute particular set of statement. Otherwise, check another. We will move to check second condition only when the first condition becomes false. Otherwise, we need not to move ahead. If the first condition becomes true, execute the particular set of statement associated with that condition and leave rest of the part. Otherwise, if the first condition false, then only check the second condition. And if second condition becomes true, execute the code associated with that condition and leave rest of the part. Means we are keep going checking the conditions. If the conditions satisfy, particular code associated with that condition only execute. Otherwise, and the rest of the code will be leave as it is. Means control will not move ahead if the particular condition satisfied, and if none of the conditions satisfy, then the code written to the last else part will execute. Means by default, if you want to execute the code, if none of the conditions satisfy, that code will be written to the last. And here I have written statement block 3. Statement block 3 will execute when neither test expression 1 is true nor test expression 2 is true. If test expression 1 true, statement block 1 will execute and rest of the code will not execute. Statement test expression 2 will only be tested if test expression 1 becomes false. Means we are seeing that different blocks of statement will be associated with different conditions. If this condition, execute this. If that condition, execute that. If another condition, execute this. we are making multiple branches depending upon different conditions. And whenever this situation arises, we want to make multi-way branching. That's in that particular situation, we will use this if-else-if ladder. And the flow chart for the same is here. If test expression 1 true, then statement block 1 will execute. Otherwise, we will test test expression 2. Means test expression 2 will be evaluated only when the test expression 1 is false. Then if test expression 2 is true, statement block 2 will execute, and otherwise if neither of the test expression 1 or 2 is false and true, then the statement block 3 will execute. That has been written in the last else part. This way we can follow this syntax to implement else if ladder concept of C language. And I have written a code to apply this concept, like write a program to check whether a number is positive, negative or 0. I have taken a number in a variable n. I have written enter a number and I scanned it in a variable n. And if n is greater than 0, print number is positive. Else if n is less than 0, print it is negative. Otherwise, print number is 0. From top to down, if number is greater than 0, number is positive will be written and the rest of the code will not execute. Otherwise, if first condition n is greater than 0 is false, then only the control will move to the else if n less than 0. And if it is true, number is negative will be printed. Otherwise, if this condition is also false, then the else part will execute. This way, we can see that the filtering of the conditions are being done. That's why this statement is very efficient to be implemented. Here I have taken a number 25 as the input, and in first condition it evaluates to be true, and so number is positive will be printed and the rest of the code will be left as it is. Now write a program to compute the roots of quadratic equation. If you want to compute the roots of quadratic equation, I have written this code also. I have input the coefficient of the quadratic equation ABC in a variable ABC. Then I have evaluated the discriminant as b square minus 4ac, and to evaluate b square minus 4ac, we have to write b into b minus 4 into a into c in C language, and I have assigned this evaluated value of d are assigned to the variable capital D, and I have checked the condition now. If d equals to 0, then the roots will be equal, and that is equals to minus b upon 2 into a. Means if the discriminant value is equals to 0, the roots will be same, and that will be minus b upon 2 into a. I have assigned x1 and x2 variable for the root, and the roots are equal will be printed and the roots value will be printed like this. Otherwise, else if, here the condition will move only when the first d equals to 0 will evaluates false. Then we will move to the next condition, and else otherwise if d is greater than 0, then the two different roots will be evaluated as x1 and x2 minus b plus b square minus 4ac. As we already know in mathematics that if the d discriminant value is greater than 0, then the roots there will be two different roots, and the first root is minus b plus under root b square minus 4ac upon 2a, and for that b square minus 4ac has been put in d variable, and for under root there is a sqrt function. I have passed this d to that sqrt function will evaluate the square root of this variable d, and that I have assigned an d1 variable, and means x1 equals to minus b plus minus b square minus 4ac minus b under root b square minus 4ac has been put into d1, that has been written here, minus b plus d1 upon 2a is the first root, and the second root is minus b minus d1 upon 2a. This way two different roots are evaluated and printed. Okay. Now, otherwise, if both d is not equals to 0 or not it is greater than 0, then means it is less than 0, then last I have written the roots are imaginary, and there is no need to check the last condition, because if the first and second is not true, then the d will be less than 0, and in that situation by default the roots are imaginary. This way we can find the roots of quadratic equation. If the value of a, b and c are 1, minus 3 and minus 4, then the roots are real and distinct, and this three different roots has been two different roots has been printed. Now the another conditional statement that is most widely used is switch statement. Switch statement is the most widely used multi-way decision making statement, and its running time is very awesome, very efficient, most efficient, because it has to check the test expression for equal condition only. Equality case value has to be checked only. Here is the syntax for the switch case statement. We write switch, and in bracket we write some test expression, not test expression, we write some expression, and the value of this expression are evaluated, and for the different value of the expression value we makes different cases like this. In the switch block we have written case space value 1, what will the value 1 is the evaluated value of the expression. If the expression value is value 1, then the statement block 1L will execute, and the break keyword, I will explain why we have written the break keyword here. Then the case value 2, the statement block 2 will execute and control will break. Then the condition case value 3, statement block 3 will execute and control will break, and this way if there is a last case, that is default case, and the default value will evaluated. Here the expression is evaluated, and for its different value expression, if the value of expression is value 1, then the statement block 1 control will go to the case value 1 and the statement block will 1 execute. If the expression value is value 2, expression is evaluated to the value 2, then the case value 2, the control will come to the case value 2 and the statement block 2 in that case will execute and control will break. For if expression value is such that it is neither value 1 nor value 2 nor value 3, none of the case value is equals to the expression evaluated value. If the expression evaluates none of the value 1, 2 or 3, in that situation the default case value will execute, default case will be executed. Default case may be put anywhere in the switch statement. It is not mandatory to put the default statement to the last statement. It can be put anywhere in the switch block, but it will execute only when none of the case value is equals to the expression value. Okay. Now comes to the another point, why I have written the break statement here. The task of break statement, whenever a break statement is encountered, the control will come outside that block. In wherever the break keyword encounter, the control will jump out of the block. If we do not write the break keyword and the expression value is equals to value 1, then the case value 1 will be evaluated, and since there is no break, then the rest of other cases will also evaluated and executed. If the control will comes to the case value 2, statement first statement block will not execute, because expression value is equals to the value 2, control will come to the case value 2. So statement block 2 will be executed, and since there is no break, then the cases after that case value will also execute. So that's why we required the break keyword, so that the control will come to that particular case value and execute that particular block, and then when the break encountered, control will move to the outside the switch expression. That's why the break keyword is very much important. Now it is very fast because expression value is evaluated and it is just checked by equality condition whether its value is equals to value 1, 2 or 3, and depending upon the evaluated expression value, the control will jump to that particular case, and particular case will execute, and by break it will come out of the block, and default will execute only when the expression value is there is no matching case value. Then in that situation default case will execute. Now I have already explained it, but there are certain important things. First, the case value can be integer only. Case value can be integer or character. It cannot a string, it cannot a float value. It can character or integer. That's why whatever is passed to this expression, the expression passed must be evaluated as a character value or as a integer value. It cannot be evaluated as a string value or a floating value. The case value may not be a float value. It has to be taken care. Okay. Another, default can be placed anywhere inside the switch. I have already told you. And break is not mandatory inside the switch, but if it is not put, then in that situation rest of the case will also execute. No limit on number of cases you can make in number of cases. Case value will be expression consisting of constants only. Now here is the difference between if else and switch case. If else, it contains multiple expression with multiple choice, and in switch case it contains a single expression for multiple choice. In if else, it tests all for all relational logical operation, and in switch case there is only equality are checked. In if else, evaluates integer, character, pointer, floating, anything, but in switch case its expression must be evaluated as integer or character only. In if else statement, editing is difficult in nested if else, but in switch case editing is very much easy. Here is a program to make a simple calculator using switch case statement. Write a program to make a calculator to simulate a calculator using switch case statement. I have taken A, B, C as a variable. I will take two operand in A and B, calculate the result and put it in C variable, and I will apply a operator op on those operands. And I have taken two numbers and input it in A and B. Then if f plus std in is just to flush the buffer of the keyboard, so that the exact value may be taken as input. Then enter a operator, and the operator is scanned in the op variable. Now I have passed this op variable to the switch case expression, and for the different case value of, if op is plus, then I have created a case. In single quote I have to write plus, because op is a character, means op value is a character. If it is case, if the case value is plus, then I have evaluated the addition of A and B and printed that. and break keyword is written to make the control outside the switch. Similarly, I have made the case of minus, then multiply, then divide. Okay, and finally I have make a default case. Here I have written an invalid operator, and it will execute when the user enter neither plus nor minus nor multiply not divide. He entered some another character. In that situation, default case will execute and print invalid operator. I have entered, I have executed this program, written a message, entered two number, I have entered 6 and 5, enter operator. Let's say I have entered a multiplication symbol, then the op value is multiplication symbol, it has been passed to the switch statement, and op value is star. Then the case is checked, equality condition is checked with this op star, and the case of star is find, and this way the multiplication is evaluated and printed. This way we can use the switch case statement. I hope you understand all the conditional statement. We will cover the looping in the next video. We will meet ahead. Thank you. Thanks a lot.